Hi guys. So today we are going to solve this problem, and before solving this problem we will discuss about chi-square distribution. Okay, so let me write down here chi-square distribution. Okay, so in a normally distributed population, in a normally distributed population with variance sigma square, if we select random samples of size, if we select, this is a random sample, so this is exactly independent random sample. Okay, if we select independent random sample of size n, and for each sample we compute sample variance S square, right? This is the notation for sample variance, and this is the notation for population variance. The sigma square is the notation for population variance, and this S square is sample variance. The sample statistics, okay, n minus 1 times S square over sigma square has a sampling distribution, have a sampling distribution called the chi-square distribution, called the chi-square distribution. Okay guys, so in a normally distributed population with variance sigma square, we select independent random samples of size n. Okay, and for each sample we compute the sample variance S square, and the sample statistics n minus 1 S square over sigma square has a sampling distribution which we call chi-square distribution. So the chi-square distribution is denoted by this, and is defined as n minus 1 times S square over sigma square. So you note that sample variance S square is, right, the best point estimate of the population variance sigma square. Variance sigma square. And sample standard deviation S and sample standard deviation S is a point estimate of population standard deviation sigma. Okay. And then let's talk about the properties of chi-square distribution. So the chi-square distribution is not symmetric. So chi-square distribution is not symmetric. Is not symmetric like normal and t distribution. Okay, so the density curve for chi-square distribution looks like something like this. Okay, this is not symmetric. You know, for the G distribution we have a symmetric, something like that, right? This is symmetric right here, but for the chi-square distribution the density curve is not symmetric. Okay, and the next property of the chi-square distribution is the chi-square value is 0 or positive. The second property is the value of chi-square distribution is 0 or positive. And you see the density curve for the chi-square distribution always lies in the first quadrant, right? We have a density curve like this, something like that. So it lies in the first quadrant, so it cannot be negative. Okay, and third property, the degree of freedom you know, the n is sample size, so this is n. The degrees of freedom we denote it by df is always given by sample size minus 1, n equal to 1. And as the degree of freedom increases, okay, the chi-square distribution approach to the normal distribution. So this is also very important. Okay, as the number of degrees of freedom increases, the chi-square distribution approaches to normal distribution. Okay, so these are the properties of chi-square distribution. Now we can solve this problem so let me read this problem. Okay, so a chocolate chip cookie manufacturing company recorded the number of chocolate chips in a sample of 60 cookies. The mean is 23.84 and the standard deviation is 2.23. Construct a 80% confidence interval estimate of the standard deviation of the number of chocolate chips in all such cookies. So we are supposed to construct, right, a 80% confidence interval estimate of standard deviation of the number of chocolate chips in all such cookies. So first of all, the confidence interval estimate of the standard deviation is given by n minus 1 s square over chi square r is less than sigma, this is radical here, is less than radical n minus 1 s square over chi square L. So this is the right-tailed critical values and this is the left-tailed critical values. Okay, so we know the sample size here in this problem. You know the value of n is, I think it's given here, this is 60 cookies, right? So n equal to 60, this is the sample size. And we also know the value of sample standard deviation, right, which is 2.23. Then we have to find these right critical values and the left critical values. Okay, so how to find that? You guys know that. So if I so you have a right. So your density curve for the chi-square distribution is look like this in this case, because you know the sample size is 60, so it's approach to the normal distribution, and this is your critical value chi-square L, and this is your critical value, this is your critical value chi-square R. Okay, so we have to find out these two values to construct the confidence interval. Okay, so how can you do that? So you guys know that we are going to construct 80% confidence interval. So that means the confidence level is 80%, and we define confidence level as the probability 1 minus alpha, which is 0.8, right? So that is, if you solve for alpha, then you will get 0.2, right? And if you divide both sides by 2, then you will get 0.2 divided by 2, which is 0.1, right? So this chi-square L is exactly, this is the chi-square 1 minus alpha over 2, right? Which is chi-square 0.9, because 1 minus alpha over 2 is 1 minus 0.1, which is 0.9, and this chi-square R is chi-square alpha over 2, and you guys know this alpha over 2 is just chi-square 0.1. So that means you see this area is 0.1, right? And this area is also 0.1. Okay. So now if you look at the table, if you look at the chi-square distribution table, so you can find out, okay, so you can find out the values. If you look at the chi-square distribution table, then you can find out the values. So with degree of freedom, so the degree of freedom D of here is n minus 1, which is 60 minus 1 equals to 59 with this degree of freedom, and the areas to the right. So you can find out this chi-square L, whose value is 45.577. So this value we got from the table, okay? And similarly, the right critical value chi-square R with degree of freedom 59. So this is from the table. So this is 279. Okay. So in the table you have to look the area to the right. Okay, now this area to the right, if you look here, this is 0.1, so the area to the right is 0.9. So in the distribution table you find out the left critical values for degree of freedom 59, and area to the right is 0.9. okay, for the area, cumulative area 0.9 to the right of this value, right? And with degree of freedom 59, you can find 45.577 as the left critical values. And similarly, with the area 0.1 to the right of this, and with the degree of freedom 59, you can find 73.279 as the critical values. Okay, this is the right critical values. Okay, so now you see we got the value of n, we got the value of s, and we have the value for the left critical values, and we also have the right critical values. You plug in here and then you solve, you do some computation, then you will find the confidence interval estimate of the standard of the population standard deviation. Okay, So now let me erase this now. So let me do some math here, okay guys? So this gives me the square root of, so n minus 1 is 60 minus 1, which is 59, right? Is 60 minus 1, 59, and my s square is 2.23 square, okay? This over, this is my square. This over, what is my right critical values? 73.279 is less than sigma is less than, so I have again n minus 1, the value of n is 60, right? 60 minus 1 is 59, and I have the same s square, n minus 1 s square, right? So 2.23, because sample standard deviation is 2.23, right? 2.23 square over, and what is my late critical values? So this is 45.577, right? 45 point, yep, so 45.577, 45.577, and let's do some computation. I think like if you use the calculator to compute this, so you will end up with 4.00389.061 is less than sigma is less than. So if you use the calculator and if you calculate that, it would be 6.43 6.43781, something like this. 6.43781, something like that. Okay guys, so and then you take the you evaluate this radical, right? So you'll have a 2.00 something like, yeah, 2.00 is less than sigma is less than, this is 2.54. if you round up to 2 decimal places, so you'll get 2.54, right? So now this is the 80%, this is the 80% confidence interval estimate of the standard deviation of the number of chocolate chips in all such cookies. Okay, so this is your final answer. Okay guys, thank you.